Right, welcome back. We're doing 4.6, example 3. We're going to use CPCTC, otherwise known as cupcake. We're going to use this in a 2-column proof using statements and reasons. We haven't done that quite yet, so they're asking us to do something a little bit different than what we've done the last couple of times. The last couple of times they have asked us to prove other parts are congruent, and we would finish our proof with CPCTC. We're not going to be able to do that this time. We're going to prove that segment ED is parallel to segment GF. And so we're going to have to work backwards just a little bit. What would I need to know if those two lines are parallel, and treat like the DG segment as like a transversal that's cutting across DE and GF. It would be very helpful to know if the alternating interior angles were equal. So that's really our goal, is to prove that. Not going to be able to prove that with all the other stuff that we know. We're going to have to probably use CPCTC to prove that those alternate interior angles are equal, thus proving that the lines are equal, those segments are equal. So it does help. We can't use CPCTC, otherwise known as cupcake, in my class. Can't use that until you've proven that the triangles are congruent. Okay? So that's where we really need to start. So if you're like, I don't even know how to plan this thing out, your first plan is prove the two triangles that you see there are congruent. Then we can use CPCTC, and then once we understand, what the angles are that we're looking for, maybe we can use some converses that we learned in previous chapters to help prove that the other sets of lines that are there. One set of lines has been given are parallel. We need to prove that the other set of lines are parallel to each other. Okay? So does that kind of give us a little bit of a game plan, I hope. All right, so let's put statement 1. Let's go ahead and mark that EG, segment EG is congruent to segment DF, and we'll go ahead and put down that that was given. Okay, so as I'm looking at my information here, my given information, and I'm kind of needing to plan out, I'm going to use the second part, the parallel lines, to help me figure out something here. Okay, now that's given as well. Could you have done that all in one step? Sure. But I separated them because that segment congruency doesn't help me figure out angle congruency. Only the parallel lines can do that for me. Okay, so you see what lines are parallel. Here they are, here and here. Treat this like this is the transversal that's cutting across EG and DF, okay? And what can you prove using that transversal? What can you figure out? Okay, now if you're saying, hey, I could possibly do alternate interior angles, okay? So we want to go in between the lines, okay, and find two angles on opposite sides of that particular transversal. So do you see EGD right where my pencil tip is? Okay, and then we've got the other one, FDG. Those are alternating interior angles, and we can prove that they're congruent. Okay, so angle EGD is congruent to angle FDG, and we can say alternate interior angles theorem. Good job, good job. That's exactly what we needed to do there. Okay. All right, let's take a look. Where do we go from here? So we've got We mark it here, put our arc here and here. Okay, so we know a side, now we know an angle, and maybe I should erase that to make that a little bit easier for you to see. Okay, so here's our side, here's our angle, EGD, and then FDG. Okay, so the other thing that is really jumping out at me is, do you see that they share, the two triangles share the side? Okay, so what you could do is put down, okay, segment GD is congruent to segment DG. Why can you say a segment is equal to itself? Because of the reflexive property. Good job. Good plan. So if that's what you were thinking all along, was that's how you wanted to prove it, that's perfect. So now we can prove that the two triangles are congruent. We can say, okay, triangle EGD is congruent to triangle FDG because of side, angle, side. We have side with an angle in between the two sides, so side, angle, side. And we use steps 1, 3, and 4 to prove that. So now this is the hard part. We need to use CPCTC. What is that? Okay, sorry, I don't know what just popped up there. We need to use CPCTC because our goal is to prove that these two sides here are parallel. Okay, so if you look at this as this is your transversal, then what we would need to know is maybe EDG and FGD. We need to show that those interior angles are equal or congruent. Now, how can we prove that EDG and FGD are congruent? Well, because we've already proven that the two triangles are congruent, we can use cupcake. So angles EDG is congruent to triangle, or I'm sorry, angle FGD because of CPCTC. And because we were able to prove that those angles are congruent, then our very last statement, we can now say that ED, segment ED, must be parallel to GF because of the converse of the alternate interior angles theorem. Remember what that said. We're going into it not knowing that the segments are parallel. We don't know that they're parallel. So if we see that we have alternate interior angles that are equal, then we can say that those lines are parallel. That's the converse of alternate interior angles theorem. Okay? Woo, that was a tough one. I hope I went slow enough for you to get that, okay? I'm going to give a +1. I want you to try to check it out. Don't let it ruin your day, but give it your best shot and let's see what you can come up with, okay? Do your best.